either going to go up or down.
Oh, okay. We were doing the other one. Okay.
Okay, so it looks like it's starting to go up. Keep going clockwise. You might have to turn it several times, so don't worry about that.
Oh, I'm going way too slow. Okay, cool.
Yeah, just keep going. Okay, see how the needle is going up?
Mm-hmm.
So go stop at -2, then you will have gone up 1 dB. So go ahead and keep cranking a little bit more clockwise. And when it's get to about -2, maybe just a hair more, that's about where you want to stop.
Okay.
Now, you've basically seen that it does what's in this paragraph. If the amplitude of the reflected signal has increased, that's what it did. It increased. Okay. Now what it's going to ask you to do is to move this to the left until you see a minimum reading on there. Now that you won't have to move very far, so don't be surprised if you only move a few millimeters before you see the minimum.
Okay, so you move a few, basically. All right.
What I'm going to do is I'm going to barely move it right here.
There you go. Now it's starting to go down. So just keep
Going down. At 40 dBm, huh?
How far am I supposed to go?
Oh,
You know,
there.
to where it reaches the minimum. So where it starts to climb again, then you know you've gone far enough.
Okay.
And I think you probably could go a little bit farther to the left. Let's see if it keeps going down.
There you go.
Yeah, it's still going down. Yep, now it's starting to climb. So basically right there, in your position 45,
45.
thereabouts, that is where you want to stop. Okay? And so that's the position you want to record right there.
45.
Uh-huh. Right. And your minimum SWR looks like it's about 1.9. I don't even think you need to know that. Just the position on your slide screw tube.
Okay.
Now, this is the step everyone overlooks. Now you're going to move this thing.
That's the
The crystal?
That's the crystal detector. You're going to move this over here. And if you have found the right location on here, then from here back, everything should look like it's matched. You'll know it's matched because your SWR won't vary very much. It'll be very close to 1. And so if we go and find our peak again, which looks like it's right about there, then let's go ahead and set that at 0. Now, as you move this to the left, notice that your SWR
It's going to float right at
is
the
going to
one.
be right around 1, which tells you that you have an almost perfect match at that location.
Okay.
Okay, and that's exactly what it should do.
That's
So-
indicating the matched load.
So what you did was you matched out the mismatch presented by the iris, and you did it first by placing a matched load on here, and that matched load means that the resistive portion of this is equal to the resistive portion of the impedance along the waveguide, right? The resistive portion is represented by that number right there. Right. Once you have done that, what you're looking for is the specific location along this length of waveguide where by placing the thing at position 45, you found the portion of the varying impedance along here that also has a resistive portion equal to the matched position. That was the significance of that P1 and P2 location from before, right? So you found that position at position 45. Then by placing the probe in and out of this thing, you are creating something that is purely reactive, and it's reactive of the type that's exactly opposite to the reactance of that. And when you find it, you've matched it, and your proof of that is the fact that the SWR is very close to 1 back
That's
over
why
here.
it stays stabilized.
Right.
Oh, okay, so we're just matching impedances.
Exactly. It's just that you're matching a complex impedance here because you have a mismatch that is both mismatched in terms of its resistance and its reactance. So you've taken care of both parts.
Okay. Okay. Wow.
Yeah.
And it's because we got this thing.
So you did quite a bit. Yeah.
Yeah. All right.
Thank you. Thank you.